Hello everyone, I'm MD Sohel Ahmed. This work is jointly done with Fuyuki Ishikawa and Mahito Sugiyama, and we are from National Institute of Informatics. Now I'm going to talk about the presentation is testing machine learning code using polyhedral region. So at present, machine learning is widely applied in different branches of field, but develop a generic method of testing machine learning code is not established yet. So we are going to an approach to test ML code using the possible input region, which is characterized as a polyhedral region. This can be applied to any ML implementation if the polyhedral region exists. What we actually findings in our research that we testing of Lasso or implementation, and we got 98% of mutations that have been detected through our method. One of the main advantages of our method that they have no false positive. The outline of this presentation consists 4 parts. First, we'd like to mention about the generic formulation of our research. Then we want to talk about the application to Lasso. Next, we want to explain about the procedure of these experiments. And finally, summary of our research. Our assumption for polyhedron. Let us consider X, Y be an input to an ML system. In many cases, capital X is a considered design matrix, and Y is our response vector. So in that cases, we just consider our output of the system is ML X Y lambda, where lambda is a parameter vector. The seminal work Lee and his co-workers 2016 showed that many ML algorithms satisfying the following condition: Y prime such that ML X Y lambda equal ML X Y prime lambda is equal to Y prime such that a Y prime less than or equal B. AY, this is the very important condition. Actually, we applied in our research of this condition. So AY less than or equal B, which is actually a polyhedron, and that can be actually determined from X, Y, ML X, Y, lambda. So in our research of this research, we applied only this assumption, that is AY less than or equal B. So this condition is satisfied with Lasso kernel-based feature selection, and a lot of ML algorithms can be satisfied in future. Still, the working is going on. Our testing approaches. We randomly create an example pair X, Y. As earlier slide, we actually mentioned what is X and what is Y. Then we constructed a polyhedron A, Y less than or equal B from our input data set X, Y. Then this A and B computing with some lambda, which is our parameter of vector. Now the condition, if we find some y prime such that a y prime less than or equal b, and the condition mlx y lambda is not equal mlx y prime lambda, which means that there is a bug exists in the ML implementation. So our plan is try to create many different type of y prime. Then we try to check about if any y that satisfies the above condition, then we can be ensured that the code includes a bug. So the proposed algorithms. So this algorithm is actually random testing of ML code with polyhedral region. So what is actually required for this task? ML code are outer and are inner. We need to be ensured that whatever is there exist bug or not. So in the first step, we just consider for loop for 1, 2 are outer do. Then we can be randomly generate x, y, and parameter lambda. Then we compute ML x, y, lambda. Then we need to be compute a and b from the Lasso equation. Then again, we just use for loop for inner function 1 to our inner. Then we just randomly generate y prime according to the condition of a y prime less than or equal b. We compute mlxy lambda, mlxy prime lambda. So if mlxy lambda is not equal mlxy prime lambda, then we need to be terminated, which means that there is a bug exists. Otherwise, bug is not detected. Output shows that. So now I'd like to mention about the application to Lasso. We know that Lasso is very popular method for feature selection, and that's the reasons we apply our method to Lasso. In case of input to Lasso, we need to be consider a design matrix X is defined n times phi, where n equal to observation and p equal to our pictures. Then response vector y is defined phi. So Lasso solves the solution through the least square, and the following equation that can be the Lasso equation, which is beta head is defined 1 by 2 double bar y minus x beta 2 plus lambda double bar beta 1. Lasso is also a sparse solution that can be actually a coefficient is like non-zero. So in that cases, we can be obtain m equal z defined p such that beta j hat is not equal 0 and its sign vector s. So this is our experimental setup, the procedure of how can we create polyhedron. So through the Lasso for the feature selection, we can be create polyhedron. We can be create data set from our input data x and y. So interesting thing is that we can be create polyhedron on the base of our data set. So we try to create many y prime from our polyhedron, and there are a lot of features will generate through the Y prime. So we just compare about these features from our original selected features. So basically it should be like same Y prime, the generate features would be same our original selected features. But if any Y prime that is like different from the original selected features, which means that the implementation must be exist a bug. And this is the polyhedral region in Lasso. As we need to be mentioned that how can we compute A and B? So A and B is actually depend on the X, lambda, and MAS. So A and B is actually partitioned in two parts, A naught, A1, and B equal to B naught, B1. A naught and B1 is inactive constraint, but A1 and B1 is like active constraint, and that can be applied in our Lasso method. So Z plus equal FSE inverse of Z transport Z, and PEM is equal to diagonal matrix. So our background of our technique, as the polyhedron is used in the polyhedron lemma in selective inference. This can be actually mentioned Taylor and Divisionary in 2015 in their paper. So we can be generate probability distribution on the polyhedron. If we perform statistical hypothesis testing based on the distribution, then the test becomes unbiased. So our experimental setting that we test the effectiveness of our method by mutation testing. We have generated 177 mutants of Lasso our implementation. So the total number of code lines 142, and we got 4 types of mutation: arithmetic, relational, logical, and assignment. Then we have examined how many mutants we can detect. So our results, what we actually got from the experimental settings, that is in the left side, we can see that there is mutation operator, and the next column, that is like target operators, different type of target operators in these mutations, like plus, minus, multiplication, and a lot of this. Then how many mutant places, then how many mutants are exist in the target operators, and experimental settings, how many mutants detected by our method, and how many mutants detection by compile error. So yes, this is our experimental, this is our results, but it needs to be okay. And the next slide, we just mentioned about the result that we got like 45 mutants that is detected based on compile error, and our method can be detect 129, and non-detected mutants equal to 3, and this non-mutants is like this relational mutants, which is actually less than, and here we can see that total number of mutants 35, detection by our method is like 20, and compile error is like 12. So like 3 mutants we cannot detect it. And our method successfully detected 98% of mutants. which is really good. And the method is very speedy. We just need only 10 seconds to detect each mutant. And our method requires 69.51 plus minus 16.70 inputs to detect each mutant. So conclusion, we propose a testing approach for ML code. As we know that to detect ML code bugs a little bit difficult because ML depends on the training data. So it's actually changed the behavior is frequently occur. So our method is based on the polyhedral reasons, and that can be actually depend on the possible input condition on output. Our method can detect 98% of mutants of Lasso code, which is extremely good. And on the base of this method, we can be applied any ML code whenever the polyhedral condition is satisfied. So features, we have opportunity to apply these polyhedral conditions a lot of ML algorithms. So I'm still working on this topic, and yeah, that's all about my presentation. And thank you very much